For thousands of years, the question of whether the future is predetermined or not has remained unanswered. Over time, as more technological and scientific breakthroughs have emerged, we've created a clearer picture of the evidence, allowing scientists to create theories about the nature of the universe. In this presentation, I'll be taking you through a few of these theories so you can get a better idea of the issue. I'll start with Pierre-Simon Laplace's 1814 theory of causal determinism, the idea that since every action has a predictable consequence, we can foresee the future by mapping out every action and consequence on a timeline. Laplace once said, "Give me the positions and velocities of all the particles in the universe, and I will predict the future." Laplace's theory does make a lot of sense, and is probably the most simple and logical theory. But of course, quantum mechanics had to come and ruin it all. But before we even touch all the craziness of the quantum world, let's talk about Einstein's theory of general relativity. Relativity is considered to fundamentally be a deterministic theory. And why is that? Well, in general relativity, time is relative, meaning that the speed that time moves for an observer depends on where they are. For example, if you were a particle near a gravitational source, like a black hole, time would move much slower for you compared to if you were a motionless particle in the middle of space. Also, if you were a particle that was accelerating, time would also move slower. This concept is called time dilation. Now, time dilation and determinism, how do they connect? Imagine this. A black hole appears near Earth, but thankfully, it's far away enough that it does not affect the planet, but it's close enough that an observer next to the black hole could see the Earth. Now, NASA has sent you on a crazy mission to go explore the supermassive black hole. You are launched in a rocket and arrive at the black hole the next day, but the gravitational force of the black hole is so strong that time dilation has a very heavy impact on you. Time is moving much slower for you, but time is so much quicker on the Earth. That means as you watch the Earth from the black hole, you can see the future of the Earth flash before your eyes. Eventually, you would see the sun engulf the Earth in its red giant phase, while in your point of view, the whole process could have taken an hour, a minute, or even a second, depending on the strength of the black hole's gravity. So Einstein came to the conclusion that the future must be determined, because your future already exists for another observer in the universe. He's basically saying that while you move through time here on Earth, there's some random observer out there that has already seen your whole life play out. But now here's where the craziness begins. Quantum mechanics. There are many interpretations of quantum mechanics, but I'll take you through two of them: the Copenhagen interpretation and the many worlds interpretation. We'll start with the Copenhagen interpretation, a probabilistic interpretation of quantum mechanics. Now, stuff gets a little messy here. So, in this theory, events and even the existence of particles only exist when they are observed. For example, at night, when you cannot see the sun, it may not exist. Only when it is observed, or as the scientists call it, when its wave function is collapsed, does it truly exist. However, when a wave function of an object is collapsed, there are always infinite possibilities for the location and velocity of that object. I'm basically saying that there is a chance that when you collapse a wave function of an electron next to you, or when you observe an electron next to you, there's a chance that it could appear light years away from you. There's a non-zero possibility that any particle could appear anywhere in the universe. However, particles tend not to appear across the universe because the probability for a particle to move normally is extremely high. This brings us back to the idea of probabilism. The Copenhagen interpretation says that any event in the universe can happen due to chance, meaning that the future cannot be predicted according to this interpretation because any unexpected event can occur, which undermines the idea of causality, which I mentioned before about how every action has a predictable consequence. In this theory, consequences can occur without any action. Now I'll talk about the many worlds interpretation. This is actually a deterministic interpretation of quantum mechanics. In simple terms, the interpretation says that every single possibility creates its own universe. For example, by moving my arm, I create an infinite number of new universes. In this one, I move my arm down, as you just saw. But in another universe, I could have moved my arm to the right, left, up, faster, or slower. According to this interpretation, all of those possibilities were accommodated in their new universes. We were basically gliding through a maze of universes with every action we perform. So currently there are infinite versions of you and me in the infinite universes that are on the timeline. Now you might be wondering how this interpretation could be deterministic. Well, since all of the universes with every single possibility exist and are accounted for in the certain interpretation, nothing's really left for probability. It is just that all the particles in the universe are traveling through the infinite possibilities with every action they perform. That was a lot of information. Overall, just know that there's many different interpretations of the universe that are probabilistic or deterministic. Unfortunately, the correct interpretation is unknown. Hopefully, as we learn more about the universe and figure out the theory of everything, we will uncover this mystery. Thank you.